Pythagorean theorem. A right triangle is any triangle with a 90-degree angle. The hypotenuse is the longest side of the right triangle, opposite the right angle. Legs of the right triangle are the shorter legs of the right triangle that are not opposite the right angle. So Theorem 8.1, Pythagorean theorem. If a triangle is a right triangle, then the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. Most of us know this is a squared plus b squared equals c squared. What is the length of the hypotenuse of triangle ABC? Do the sides of ABC form a Pythagorean triple? Explain. We'll worry about the second question after we prove the first. So we're looking for the hypotenuse of ABC, which would be this side here. So remember, Pythagorean theorem says we're going to take a squared plus b squared equals c squared. So that means we're going to have 20 squared plus 21 squared equals c squared, because we don't know what c is yet. 20 squared is 400, 21 squared is 441. And so when we add those together, we're going to get 841 equals c squared. Well, to find the length of AB, or C in this case, we have to square root both sides of this equation. So we square root the 841 and the C. So that means we get C equals, and in this case, C equals 29. So that means the length of AB is equal to 29. So in this case, it asks, do the sides represent a Pythagorean triple? Well, yes, they do. A Pythagorean triple is any time you have three whole numbers that satisfy the Pythagorean theorem. And whole numbers are numbers without decimals. So 20, 21, and 29 are a Pythagorean triple. Example 2, the legs of a right triangle have lengths of 10 and 24. What is the length of the hypotenuse? So if we draw this out, they tell us that the legs have length 10 and 24, and they ask what is the length of the hypotenuse? So that's that guy there. Well, we can use the Pythagorean theorem again. So a squared plus b squared equals c squared. So we've got a, b, and c. So that's 10 squared plus 24 squared equals x squared. 10 squared is 100, 24 squared is 576. When you add those together, you get 676 equals x squared. Our last step is to square root. And in this case, we're going to get x to equal 26. And once again, we have a Pythagorean triple. Since 10, 24, and 26 satisfy the Pythagorean theorem and are all whole numbers, this is a Pythagorean triple. Here they want to know the value of x. Ignore this part about expressing in simplest radical form for right now. We're going to worry about just finding the value of x. So to find the value of x, we're going to use the Pythagorean theorem. The 8 in this case is a, x will be b, and c is 20. Since it's opposite the right angle, we know it's the hypotenuse. So that means we have 8 squared plus x squared equals 20 squared. 8 squared is 64. 20 squared is 400. And so now we have a problem we need to solve. Well, in order to solve this, we're going to start by subtracting 64 from both sides. We get x squared equals 336. And then we're just going to square root both sides of this equation. So in this case, we're going to get x to equal right around 18.33. Question 4. The hypotenuse of a right triangle has length 12. One leg has a length of 6. What is the length of the other leg? So once again, let's go ahead and draw this right triangle. And we can make that look nicer. There we go. It tells us the hypotenuse has a length of 12, so that'll go there. One leg has a length of 6, and we're looking for the length of the other leg. Something like that. Once again, we can use the Pythagorean theorem. So a squared, we got a, we have b, and c. So that means we've got a squared plus b squared equals c squared. Well, x squared stays x squared. 6 squared becomes 36. And 12 squared becomes 144. To solve this, we'll subtract 36 from both sides. And we get x squared equals 108. And our last step here will be to square root both sides. And this should give us x equals 10.39 or 10.4 if you round. The size of a computer monitor is the length of its diagonal. You want to buy a 19-inch monitor that has a height of 11 inches. What is the width of the monitor? So let's assume we have a computer monitor. Let's about that. And they know that the length of the monitors are done by keeping track or by measuring their diagonals. So there's a diagonal. They tell us that we want the monitor to be 19 inches, so that this has to be 19 for it to be a 19-inch monitor, and the height's 11. They want to know the width. So we're looking for this. So if we use the Pythagorean theorem, or a squared plus b squared plus c squared, we should be able to find the length of that width, or that missing side, x. So this is going to be x squared plus 11 squared equals 19 squared. So right now we've got x squared plus 121 equals 361. We'll go ahead and subtract 161 from both sides. Or sorry, we'll go ahead and subtract 121 from both sides. And we get x squared equals 240. And the last step will be to square root both sides. And we should get x to equal 15.5 roughly. So 15.5 inches is the width of the monitor. Theorem 8.2, converse of the Pythagorean theorem, states that if the sum of the squares of the lengths of two sides of a right triangle is equal to the square of the length of the third, then the triangle is a right triangle. So what they're saying here is if you have three sides of a triangle and you don't know if it's a right triangle or not, you can plug those values into the Pythagorean theorem, and if it becomes a true statement, so if the a squared plus b squared equals the c squared, then what you're dealing with is a right triangle. So first example, they tell us that we have a triangle that has side lengths of 85, 84, and 13. And they want to know, is the triangle a right triangle? So in order to figure this out, we're going to test the Pythagorean theorem. But when you label your A, B, and C, make sure your A value is your smallest measurement, your B is your middle, and then C needs to be the largest length they give you. So we've got A squared plus B squared equals C squared. So that means we're going to end up with 13 squared plus 84 squared equals 85 squared. 13 squared is 169. 84 squared is 7,056. And then 85 squared is 7,225. We'll add the two on the left together. We get 7,225 is equal to 7,225. This is a true statement, and since this is true, it is a right triangle. Since the three measurements work in the Pythagorean theorem and it remains a true statement, we are dealing with a right triangle. Question 2. A triangle has side lengths of 16, 48, and 50. Is the triangle a right triangle? Explain. So we've got A, B, and C, and we need to use the Pythagorean theorem to test. So 16 squared plus 48 squared equals 50 squared. 16 squared is 256. 48 squared, 2,304. And 50 squared, 2,500. We'll add the measurements on the left together. We get 2,560 is equal to 2,500. This is not a true statement. So that means that this is false, and this is not a right triangle. Since those three measurements do not satisfy the Pythagorean theorem, we are not dealing with a right triangle. Here we have two more theorems, and this time these theorems state that you're going to use the Pythagorean theorem to test if you're dealing with an obtuse or an acute triangle. And that means, like, if it's obtuse, that just means that its largest angle is greater than 180, is greater than 90. It's greater than 90. And if it's acute, that means all of its angles are less than 90. So if you begin the Pythagorean theorem such that you have a squared plus b squared equals c squared, and c squared ends up being larger than a squared plus b squared, you're dealing with an obtuse triangle. If you begin the Pythagorean theorem and you go to calculate your values and a squared plus b squared is bigger than c squared, then you're dealing with an acute triangle. So if the c squared value is bigger than the other two put together, you have obtuse. If c squared is less than the other two put together, you have acute. So here we have an example of this. We've got 6, 11, and 14 are the lengths of our sides of our triangle. We want to know if it's acute, obtuse, or right. So we've got A, B, and C. So we've got 6 squared plus 11 squared equals 14 squared. 6 squared is 36, 11 squared is 121, and 14 squared is 196. 36 plus 121 gives us 157. And we have 196 for c squared. So that means in this case that c squared is larger than a squared plus b squared. And so if c squared is larger, we have an obtuse triangle. Example 2. Is a triangle with side lengths of 7, 8, and 9 acute, obtuse, or right? So A, B, and C. We've got 7 squared plus 8 squared equals 9 squared. Let's see how this works out. 7 squared is 49. 8 squared is 64. 9 squared is 81. 49 and 64 give us a total of 103. C squared is still 81, but this time we know that 103 is larger than 81, so that means that a squared plus b squared is greater than c squared. So that means this triangle is acute.